Now, we are measuring length today. Measuring length. This is for the syllabus IGCSE and O levels. Okay. Now, the instruments that we use are meter rod or meter ruler. Then we have measuring tape. We have vernier calipers. Then we have micrometer, screw, gauge. Obviously, there will be some other um, instruments to measure length, but we are not concerned with them for IGCSE or O levels. In O levels, examiner is supposed to ask questions about these instruments. Now, listen, some other forms of meter, the we will first start from studying meter rod. Meter rod or meter ruler has some other versions as well. There is a version that is called half meter rod. There is a version that is called 2 meter rod. And there is another very common version of the same kind of scale, that is a 15 cm or 30 cm scale that we use in the geometry box. So half meter rod, 2 meter rod, and 15 centimeter rod, they're all the same things. Only difference is some are bigger than the others. Now, half meter rod or 2 meter rod, and where are they all used? What are the condition in which we can use them? Okay. These instruments are used if the length of object under observation is within the size of the scale, and we need accuracy up to 1 by 10 of centimeter or 1 centimeter, 1 millimeter, sorry, 1 millimeter. If we want the accuracy of 1 millimeter, we can use a meter rod or scale that is in your geometry box. They all have uh, measurements up to 1/10 of a centimeter. Mm, here we go. This is an example of meter rod. Let me go into images. 1 millimeter. 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 1 milli I think this is a good example. Yeah, there we go. Now, look, these are centimeters. Two, three, four. Do you see that those big numbers? They are centimeters. You know what is meant by centimeter? Listen, if you start from here and we go up to there, the gap between these two lines, I'm talking about this gap, this is 1 centimeter. Approximately, if you look at your thumb like this, I hope you can see my thumb, and this nail, your thumbnail, is approximately 1 centimeter wide. So 1 centimeter is actually a distance. So 1 centimeter is from 3 to 4. But if you look more closely over here, how many small divisions are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we start from here, we will have 10 divisions. You know the gap between these two divisions? I'm again talking about the gap in between. This gap is called 1 centimeter. I'm talking about this gap is 1, my bad, millimeter. Listen, from this big marker to this big marker, that is 1 centimeter, and there are 10 equal divisions in between a centimeter. Every single division is 1 millimeter. And this ruler is only good for measuring up to a millimeter. If you need to measure something with more accuracy, this, like, there are ways of using the same scale with more accuracy, but not like this. Straight away, you can only measure up to 1 millimeter, not more than that, not deeper than that. Problems while measuring from meter rod. Problems. Number one, zero error. Number two, parallax error. What are zero errors and parallax error? Listen, zero error on the meter rod. Look, mm, I hope if you can easily get to your geometry box scale right now, you might find there a problem with the scale. The problem with the scale is that, like, this is the good one. Now let me bring this one over here. Look, 1 second. Okay. Look, if I measure something using this scale and I don't mind this thing over here. This is where the scale is starting from, and this is where the readings are starting from. This difference is known as zero error. If I use this ruler somewhere, this error will be zero error. Okay. And if my line of sight is not perpendicular to the scale, then that will be parallax error. For example, if instead of making my eye over here, this is the correct position for the eye. This is correct position for eye. But what if your eye is, instead of being there, if your eye is here? Sorry. If you're looking from there, what will happen? Will you be looking at this correct value then? Now, your line of sight is like this. So you might consider this as the correct reading. Okay. So this is wrong. And this is how parallax error is comes into being. So parallax error is a kind of error that is caused because of improper position of your line of sight. If your line of sight is not perpendicular to the scale, you might be getting a reading which is a bit more or a bit less than the original reading. This difference of reading is known as parallax error. And to overcome this error, what you need to do is you need to make the line of sight perpendicular to the scale. Let me write this down because this is a very commonly appearing question in exam. No. Always measure from 0 on the scale to avoid zero error. Keep line of sight perpendicular to avoid to the scale to avoid parallax error. Okay. So line of sight must always be perpendicular to the scale. If it is not, you will make a parallax error. Okay. So be careful. One way of overcoming this thing is, for example, if this is a scale, and we cannot actually make the object touch the scale. For example, this is uh, a, a spherical thing that we want to measure the diameter of, but there's no way of making this thing touch the scale down. So either we have to just blindly measure it and just assume that the line of sight was perpendicular to the scale, or what we should be doing is we should be using some straight edge to project these things, these ends on the scale. And this is where this thing comes into action that most of us don't have any idea what are they. I hope you must have seen something like that in your geometry box. It is a plastic triangle with some scales on it. You know, the good thing is that this angle on this one is perfectly 90 degree. Perfect 90 degree. Oh, that is what we mean by perpendicular. When we say something has to be perpendicular, actually what we mean is that it should be 90 degree. So look, when I put the scales like this, now how can I measure the diameter now? Listen, the diameter is from here till here. This is diameter. So what we do is, can we see this reading? This is reading one. This is reading two. And diameter will be reading two minus reading one. So this is how we can measure diameter of something without doing parallax error. Okay. Now, one more question. Can we use the same scale that is in your geometry box? I'm not talking about any other materials that we can use, but I'm talking about the ordinary scale that you have in your geometry box. Can we use it to measure thickness of paper? How thick is one paper in your notebook? Can we use an ordinary scale to measure that? The first answer comes to mind, no. I think we can use it to measure the length of the paper. Obviously, we can use it to measure the width of the paper, but the thickness, that is so small, so tiny. How can we use a ordinary scale to measure that? Hmm. Let's think. What we can do is, instead of just using one paper, which is actually very thin, what if we measure the thickness of whole notebook? Minus those cardboards at the end. Just ignore them. Just fold them backside, or away from the papers, and then measure the thickness of the whole notebook. Then we can count the number of papers, and then we can subtract the two readings from one another, like the top reading and the bottom reading that we have on the scale, to find the thickness of the whole notebook. Finally, we can divide that thickness with the number of papers to find how thick is a single paper. Let me draw that for you over here. This is, for example, a scale. This is the notebook. Just one second. Let me draw it better. These are the pages. Now, can we find thickness of the paper, like the whole book? This one. Can you find this thickness? Yes, we can. Actually, it is a significant length, and we can find reading number one, we can find reading number two, and thickness of book. Let me make a key over here. T means thickness of all sheets of paper, and small t is thickness of one sheet. How can we measure how thick is one single paper? Total thickness will be reading number two minus reading number one, but thickness of a single sheet will be total thickness of the book divided by number of papers or sheet, number of sheet. So this is how we can find thickness of a single paper. Now, moving on, can we measure thickness or diameter of a thread using ordinary scale? Answer is yes, we can. But how? Just one second. No. This is using ordinary scale to measure thickness of one sheet of paper. So this is how we measure thickness of one sheet of paper. Now let's move forward, and now we will be measuring diameter of a thread on a reel. So there is a big reel of thread, and I need the diameter of that uh, thread. What I do is I take the ordinary scale. Okay, not ordinary scale. Let's use something else. This is, make a guess. What is this thing? So this is me trying to make a lead pencil. Now we have the thread, and what I do is I start winding the thread along the pencil. Do you see what I'm doing? I'm winding let me zoom into this one. So what I'm doing is I am winding that while winding the thread, I have to be very careful that all the threads should be side by side with each other. There should be no gap. Neither any one thread should overlap another thread. Okay. So there are n rotations. Now I use an ordinary scale on the other side. This is an ordinary scale. Using this ordinary scale, can I measure from here till here? Can I measure this one? Let's call it L. For this one, I need this reading, reading one, this reading, reading two. So very basically, the same thing we've been doing the whole thing today. Reading will be R2 minus R1. But that will not be the thickness of a single thread. This R2 minus R1 will be giving you this L. L is thickness of N side-by-side threads. What will be the thickness of one single thread? No, thickness of one thread equals to D, and D will be L divided by N. So what we do is we measure this length and we divide it with this the number of rotations, and we will be having the thickness of a single thread. And that is a very easy way of finding diameter of thread. Do you see or do you grasp the main technique over there? Because we are measuring things that are very, very small. And if we start measuring them with a meter roll, simply like directly, just one time, that will be a very small thickness and we will not be getting any reading at all. But instead, if we repeat them side by side without leaving any gap in between, and then we find their total length, and then we find their number, and using some mathematics and some divisions, we can actually find out how thick a single thing is. So this is how we can measure different kinds of lengths. So this is just length, how you should be able to measure length using ordinary scales. Now, what is measuring tape? Everything about measuring tape is same as we have done with the ruler. The only difference is measuring tape, instead of measuring things within 1 meter or half meter or 2 meter. Measuring tape is a very long thing, and it can measure long distances like length of room, height of a hall, or diameter of a log of wood. So we can actually wrap the measuring tape around around a tree and measure its circumference, and then use circumference formula to find diameter, radius even. So measuring tape is the same thing as like all other measuring techniques are same. They also measure up to 1/10 of a millimeter, 1/10 of a centimeter, sorry, 1/10 of a centimeter, like meter rod. So everything about measuring tape is same, used to measure large lengths, used to measure large lengths like height of a room or length of a car. So these kind of things are you measure using measuring tape. Now, and remember, measuring tape can also measure the same, like limitations are same. can measure up to 1 by 10 of centimeter or 1 millimeter, like ruler. So they can also measure up to 1/10 of centimeter or 1 millimeter. Now, what are vernier calipers? Remember, it is a device that can measure up to 1 by 10 of millimeter or 1 by 100 of centimeter. This device can measure external as well as internal dimensions, uh, thickness of one surface on the other. So these are the things that we can measure using vernier caliper, and the good thing is that the vernier caliper can measure up to 1/10 of a millimeter. So if we are using a vernier caliper, we can actually measure thickness of a paper without doing all this. We can just simply put the values in. Now, let's see what micrometer screw gauge is capable of doing. Now, micrometer screw gauge. Micrometer screw gauge can measure up to 1 by 100 of a millimeter or 1 by 1,000 of a centimeter. So this thing can measure very small things with very high accuracy. What we have to do is we just have to put things in between the jars, and then we close the jaws. Whatever comes in between, that will stop the jaws from moving closer together. Then we can measure the reading from the main scale and the circular scale. So micrometer screw gauge are they are best for measuring small things. Now, can only measure external dimensions, uh, useful for small things like diameter of an electric wire. If we want to measure how uh, wide is or how thick is a single wire of electricity, we use uh, micrometer screw gauge because that is very good in measuring things that are very, very small. So tomorrow we will be learning about vernier calipers and how we make vernier calipers and we make readings from vernier calipers and how we take readings from micrometer screw gauge. And after that, we will move on to measuring time and measuring mass. So that's it for today. See you people tomorrow. Take care. Allah Hafiz.